Okay, so today we're going to be talking about scatter plots and lines of best fit. So again, bivariate data, scatter plots we've done before. The one thing we want to talk about at the end here is going to be association and correlation, which is just the relationship between the two variables that are dependent on each other. We'll talk about a couple different examples of these. Strong versus weak association. Here, positive correlation means that as my x increases, my y increases as well. The most important thing is that, again, this is my positive slope. We've actually talked about this already this year when we actually did lines of best fit before. But if you have a positive slope, that means that you're going to have a positive correlation. The two different types of positive correlations you have is you have a strong positive correlation, which your correlation coefficient is going to be somewhere around 0.7. The closer to 1, the stronger the correlation is. Correlation coefficient is the same thing as your R value, which we can find on our graphing calculator. The weak positive correlation, again, it's not quite as tight of a pattern. It's a more of a loose pattern, less predictable, and then that correlation coefficient is going to be farther away from 1 and closer actually to 0. Again, negative correlation is going to be that as my x increases, my y decreases. The best way to think about it is it's negative slope. It is going down as we travel from left to right. Again, a strong negative correlation is the points are tight together. They are clustered in a predictable pattern, and then our correlation coefficient is going to be from closer to negative 1, so around negative 0.7 to negative 1, and again, that's our R value. And then a weak negative correlation, again, it's a loose pattern, less predictable. Correlation coefficient is going to be closer to 0, probably someplace around that negative 0.3 to negative 0.7 category. And then the last one is if there's no correlation, there's just no pattern, and then our R value is going to be close to 0. That'll just be kind of like random dots, if we think about snow falling down, that's kind of that no association or no correlation. So when we have something like this, again, if we were to draw points on this, if I have a strong positive correlation, again, if it's positive, that means that it's going to be going up from left to right, and that they're going to be tightly, tight together, the points are. So if I have something like this, and I draw a line of best fit, those are all pretty close to that. That's a strong positive correlation. Weak positive correlation is going to be, again, same thing. So if I put a little more space in between them, so you can still see that there's a general trend upward, but those points are farther away. And then no association, if you just kind of draw, we've got snow like that. There's no rhyme or reason. It's just kind of all over the place. Strong negative, again, these are going to be the same things. It's just going in a negative direction. So here, again, I've got a strong negative correlation. They're pretty tight along that line of best fit. They are going down as we go from left to right. Weak negative, again, just more space in between them. Something like this, where, yeah, you can see that the general trend is going down, but it's a looser correlation. We can't necessarily see that tight as close to that line of best fit. And so if I look at something like this, again, I just want to choose which one of these correlation coefficients. Again, the closer to 1 means a strong positive correlation. The closer to negative 1 means a strong negative. And then if you get closer to 0, that's where it's looser. So with this first one, the hours that you study versus your test score. If I were to draw a line of best fit, I could probably draw a line of best fit that looks something like this. There's not a whole lot of space in between each of those points, the pieces of data, and the line of best fit. And so that's a pretty strong positive correlation. So again, by process of elimination, I know that it's not going to be either of these negatives because it's going up from left to right. And then I can choose, is it strong or is it weak? And it looks like that's pretty strong. So I'm going to call that a 0.9 correlation coefficient. That's my R value of 0.9. Here for this one, car weight in miles per gallon. Again, if I were to draw a line of best fit, it'd be kind of something like this. Again, we should be able to see that it is a negative correlation, so I can already go out and cross off the two that are positive, and then I can just choose, is it a strong correlation or is it a weak correlation? It doesn't look like it's quite as close and tightly knit as the last one, so we can go with it is a negative 0.6 because it's not super tight. It's a little more of a loose correlation. Again, we've done trend lines before. That's just a line of best fit. It's kind of what the words that we used, I think. Trend line that models the relationship. What we have here is, so we can do a thing called residuals, calculating residuals, which is going to be, I guess the easiest way is it's going to be subtracting the predicted value, so the line of best fit, from the actual value. And this is going to be, basically what we're doing is we are measuring how far vertically the dots are from our line of best fit. So with our first graph here, each of these lines are going by fives. So I got, there's 110, 115, 120, 25, 30, 35, 40. So making sure that we understand our scale. And now when I do this, each of these dots, I'm just going to see how far are they away from my line of best fit. So with this first one right here, I can kind of draw down. Right there, that is half of a square, so that'd be 2.5. It doesn't look like a very good 2, does it? There we go. So that is 2.5 away from our line of best fit. Okay, so that's a one residual value. This one, again, is half a box, so that's another 2.5. This one right here is a box and a half, which is 5 plus 2.5, which gives me 7.5. And again, these two dots right here, they're actually on the line of best fit, so they're right on the money. They are 0 away from the line of best fit, so that's why I didn't put a number there. If I wanted to put a number there, it would be 0. This one right here is 2 boxes away, which is 10. Half a box away, which is 2.5. And then 1 box away, which is 5. And so again, what I can do to get a residual value for all this is I can add together each of these numbers. Let's see. We got 5 and 10, that's 15. 15, 7. So that should be 30 for our residual value here is going to end up being 30. That was the total that we were off from our line of best fit to each of those points. Now if I go to this other one, do the same thing. Again, I can go, scale's still going by fives. So that one right there, that point is 10 off. This one right here is 10 off. This is 5 off. This one right here is, 15 off? This is 5 off. This is 10 off. This is 5. And that last one was right on the money. So again, these are, if you notice, the dots are exactly the same from each graph. It's just a different line of best fit. So we're trying to figure out which line of best fit is better. So 10, 20, 30, 40, 50, 60 for this one. So this one was 60 off. So you want the one that is closer. So it says which line is a better fit for the data. We know that line A is better fit because the points are closer to the line. So So each of those points are closer to the line of best fit. So that's what we're kind of going for there, okay? For this one, we're going to talk about what's the slope and what the y-intercept mean in these. So for this first one, this is actually that same one. So as I'm moving to the right, that's at the age that people go. And then the other direction, my y direction, my heart rate is, as we can see, it's going down. So what we need to remember is that our slope is our rise over our run. So again, that is how much we go up or down over how much we go left or right. So in this one, our rise is our heart rate. Ooh, I could draw a heart. That's a pretty good heart, right? So my heart rate is going down. And then the trick is I'm always going to the right with my moving on my x-axis. So as my age is going up in years, so going to the right in years. And so I want us to kind of get in the habit of kind of being able to write it out. So your heart rate goes up as we get, that should be a down. Heart rate goes down as we get older. So as we increase in age, our heart rate goes down. Our y-intercept then, remember that your y-intercept is where your graph meets the x-axis. And so I'm going to put a big old dot right about there. That's my y-intercept. And so, again, my y-intercept is what is my starting point. In this case, my starting point is when my age is at 0. And so, again, try to write something that makes sense with words. Don't say when your age is 0. The common sense way of saying when your age is 0 is when you're born. So when you're born, your heart rate, and that looks like 140, right? When born, heart rate is 140 beats per minute. Okay, so again, we're trying to as much as possible kind of use words to explain what the slope and the y-intercept actually mean. So with this second one, it's talking about the months you're employed at a job and your hourly rate. And so when I do this, again, my slope, is my rise over my run. My rise is my hourly rate. I'm going to put it as pay. So my pay goes up. And then the bottom is months employed. Months working. As I work longer, my pay goes up. And so when I do this, again, I want to try to write like a little sentence. My pay goes up as I work longer. And that should kind of make sense, right? My y-intercept, again, I can take this, put a little dot there, circle it. That's my y-intercept right there. My y-intercept, so again, when I'm talking about my y-intercept, I'm talking about in the beginning. So when my x is 0, so when my months employed are 0, again, try to come up with a common sense verbiage for that. So when I am hired, so when I am hired, I get paid. What is it, $7.50? Yeah. There you go. Okay. Just one last thing real quick then. I'm going to skip that one. Same thing, okay? Correlation and causation. Sometimes we can get these things a little bit confused. So a correlation is just when you have a relationship between two things. And then causation is when the change in one causes the change in the other. Sometimes correlation and causation get confused together to where you can say that one thing causes the other when it's actually just something that is maybe a little bit of coincidence. You want to make sure there's actually proof that one causes the other. And that's what this says right here, is just because two things are strongly correlated, we can't assume that one causes the other. A lot of times when people are reading statistics and stuff like that, they want to associate two things together, saying one causes the other when it's just strongly correlated. So the first one that you have is, it says that the height of a plant increases as the amount of sunlight it receives increases. So plant's height increases as the sunlight it receives increases. So is that correlation? Yeah, that's a correlation. As one increases, the other increases as well. And then the causation here. Do we know that sunlight causes plants to grow? Yes. That's called photosynthesis and chlorophyll and all that stuff. So we know that sunlight causes plants to grow. So this would be correlation and it would be causation. Sunlight causes plants to grow. The next one, a survey of a class shows a student who gets lower grades spends more time sleeping each week. Correlation? Yeah, it could be a correlation that as people who spend more time sleeping get lower grades. That could be a correlation that we have. And then causation. Does sleeping more cause students to get lower grades? No, not necessarily, because there's a lot of other factors that could be weighing in there. You could have a student who doesn't sleep at all who gets really bad grades. You could have a student who sleeps a lot but gets good grades. It doesn't necessarily mean that sleeping causes you to get lower grades. It's just a correlation for this class. Okay.